So we're going to talk about several graphs, and they're going to include speed, velocity, distance, position, displacement, and time. A position versus time graph is going to show you the details of actual motion during the trip. Before we talk about those, we want to talk about two terms. So average speed is the total distance that you're traveled divided by the total time taken. And that's usually what we're calculating when we calculate speed or velocity. And then we also talk about instantaneous speed, and this is the speed that you're usually talking about in everyday life. If you look on your speedometer, that's your instantaneous speed. That's the speed you're going at that second. If a police officer has a radar gun and they use that to see what speed you're going, that's instantaneous speed. If you use your cruise control in your car, that's going to be average speed. If you set it for 65 on the interstate, that's going to be the average speed you're going to go. You might go a little slower than that when you're going up a hill, or a little faster than that when you're going down a hill, but that'll be your average speed. Okay, so here's our first graph that we're going to interpret, and this is a distance versus time graph of a boat that's traveling through a long canal. The boat has to stop at locks for changes in water level. So it's our job to look at the graph and see how many stops it makes. And so we need to do that by looking at the axes here. So we have distance and we have time at the bottom, and we want to see what parts of the graph are going to show us that it made a stop, and we need to count them. So the different parts of the graph that I see, we have several things here. We have this is a part that are very similar. We have increasing sections, and then we have flat sections here. So those would be our two options, right? And if we look at the distance side, this is going to be much like the yards on a football field. If you're a football fan, you can picture it that way. Or if you're more of a math-oriented person, you could picture a number line. Okay, so this is going to tell us exactly where that boat is at any given time. And then the bottom's going to tell you the time in hours. Okay, so we need to figure out which one of these tells us that we have made a stop. Okay, so which one makes sense? Does it make sense that this part that's going up means that we made a stop, or this flat part means we made a stop? Okay, so this flat part right here, let's take this first one for example, means that you are at 20 kilometers and that you stay at 20 kilometers from 1 hour to 2 hours. Okay, and then this flat part means that you stayed at 40 kilometers from 3 hours to 4 hours. So these flat parts, the straight parts that are flat, that is a stop. And so how many stops did we make? We made 3 stops. Okay. So the upward angled parts are where you're changing position, you're going forward, and then the flat parts are stops. Okay, so the next question says, what is the boat's average speed for the whole trip? So remember how to calculate average speed. Speed is distance over time. So the total distance that we went was 100, and the total time it took us was 10 hours. So 100 divided by 10 is 10 kilometers per hour. So that is our average speed for the whole trip. What's the highest speed the boat reaches? So you can do a calculation here. So we already know we're stopped during these moments, so we will ignore those sections, and then we could calculate the speed of each of these sections. Okay, or we can use a little bit of common sense. Okay, so these 3 speeds right here are all the same, right? Because the angle of those lines are all the same, and the angle of this one's different. So the question is, which one's faster? Okay, and these first 3 sections, they're covering a distance of 20 meters in 1 hour. In this last section, they're covering a distance of 1, 2, 3, 4. So, in 4 hours, they're covering a distance of 40 kilometers in 4 hours. Okay. So, the first 3 sections, they're all going the same speed. So what is the highest speed the boat reaches? 20 kilometers per hour. And that would be at 0 to 1 hour, 2 to 3 hours, and 4 to 5 hours. It doesn't ask us for that specific information, but okay. So the next thing we want to talk about is slope. This is review from math. Pretty much everyone, I think, remembers talking about slope. If you need a refresher about what it is, slope is the line of a line is the ratio of the rise to the run. So the vertical change to horizontal change. Okay, so you just need to memorize this if you don't have it. Slope is rise over run. So you literally take a section of the graph, count the boxes up, divide that by the boxes over. Okay, and that equals the slope. So why would we want to know the slope? Because the slope is going to equal the speed, like we just calculated. Okay, we just did that on the previous slide. So in this particular instance, if we do that, you go 10 up, 10 over, 10 divided by 10 is going to be 1, right? Okay, so this is a position versus time graph. How does that correspond to velocity? Well, we just talked about it a little bit, but this one has a little bit different information on it. So here's section A, and we're stopped here, right? I know it's stopped because the position hasn't moved. We're at 60, so say we're on the 60-yard line if we're playing football, and we haven't moved from that 60-yard line. So we're stopped here as well. Here's section B, here's section C. Okay. So on sections A and B, we're said to have an increasing velocity or positive velocity. In section C, we're said to have a negative velocity. All that means is you're going backwards here, or the opposite direction. Okay. And the other thing we can talk about here is the slope. You can think of these as a hill in sledding. Okay, you guys have probably been sledding a lot this winter. So whatever section looks the steepest is going to be the fastest. Okay, so you can calculate it out to confirm that if you need to. Okay. So when the direction of motion is part of the calculation, that changes in position are referred to as displacement. We've talked about that. The average velocity uses the values of displacement and elapsed time from the position versus time graph. Okay, we've talked about that. So velocity includes direction as well as distance, okay? And this one's backwards. This one's forwards. Okay, so now we can calculate the average velocity at segment C here. So we want to take the distance that was traveled, so that's 90 to 0, right? So that's 90 miles. And the time it took, so from 3 to 4.5, so that would be 1.5, right? So if we divide that on our calculator, that would be 60 miles per hour. Okay. Okay, so now we want to talk about the slope of a position versus time graph at any one time, and that's going to be called the instantaneous velocity.